Welcome to the next lesson in our trigonometry unit. The lesson here is going to focus on something called the cast rule and how we can use it to solve trig equations. So the goal here is that we can use the cast rule to identify which trig ratio will be positive in which quadrant, and we can solve for an unknown angle given the trig ratio. All right, so your first job is actually to do example number 1. You don't need my help for this. You're just going to take your calculator and calculate what the sine of 20 degrees is to 4 decimal places. So for example, when I do that on my calculator, the sine of 20 degrees, I get 0.3420 approximately. 0.3420. So take some time here, calculate these things, and then we're going to talk about the commonalities that we see. So you can go on to do part I down here, which says what patterns or commonalities do you notice about each column? So looking downwards, A, B, C, D, and then E, F, G, H compared to each other, and then I, J, K, L compared to each other. And then what patterns or commonalities do you notice about each row? So A, E, I compared to each other, what do you notice about? And when you're looking for those commonalities or patterns, look at your answers, but also look at the questions and how I've set them up. So there's commonalities in both your answers and your questions themselves. So take some time and do that. Okay, so if you filled in all your values here for your trig ratios, and I just am going to get the 20 degree of tan of 20 degrees in here. That's 0. Oops, what's going on here? There we go, try this. 0.36397. So that's going to round to 39, would go up to 40. So what we noticed is that each column focuses only on one of the 3 primary trig ratios. So the first column here is all sine ratios, this column is all cos ratios, and this one's all tan ratios. The answers in the columns are the same, except 2 are positive and 2 are negative. And I'm going to tell you right now, I know that this one, it will be positive, 0.3420, while these 2 will be negative, but the values will be the same, other than that there's the negative instead. Okay, and I could have told you which ones were going to be positive and negative ahead of time, and that's where this thing called cast comes in. For this one, this should be a negative, but still the same ratio. This one should be a negative, but the last one on this one will be positive. And then for tan, the first one was positive, and the middle one was positive here, and the other 2 were negatives. Okay, and we'll talk about why that is in a moment here. What else did I notice for each column? The 4 angles in each column lie in different quadrants when graphed in standard position. So the first row, these ones are all in 20 degrees is in quadrant 1, 160 degrees is in quadrant 2, the 200 degrees is in quadrant 3, and the 340 degrees is in quadrant 4. So the 4 angles in each column lie in different quadrants. So in the row, they're all in the same quadrant. Each of the angles has the same related acute angle of 20 degrees. So first one, 20 degree related acute. 160 degrees, it takes 20 extra degrees to go to the 180. 200 degrees, that's 20 degrees off of the x-axis, below the x-axis. And the 340 degrees is 20 degrees below that 360 degrees. So that's a key factor in why the trig ratios all ended up being the same value, although some are positive and some are negative. If I take this, the sine of the related acute angle, I will always get this value here, the sine of 20 degrees. The related acute angle is the same. What patterns or commonalities do we notice about each row? Well, I've already mentioned that they all, the first row is all first quadrant angles, the second row all second quadrant, third row, third quadrant, fourth row, fourth quadrant, and in fact the angles are the same for each. It's just we're doing it for the 3 different primary trig ratios. I'm also noticing in the first row all 3 trig ratios are positive, but then when you get to the next 3 rows, only one of the 3 is positive. So in the second row, only sine is positive. In the third row, only tan is positive. And in the fourth row, I should be underlining these so you guys can follow along. So in the second row, only sine is positive, in the third row only tan is positive, and in the fourth row only cosine is positive. Now here's where cast comes in. Do you see that cos starts with C, tan starts with T, and sine starts with S? So there's the C, there's the S, there's the T. In the first row, all three, A for all three were positive. So cast is a way of telling us in what quadrant which trig ratio will be positive. So if I draw my Cartesian plane, so representing angles in standard position, this is quadrant 1, this is quadrant 2, this one's quadrant 3, these are Roman numerals, this is quadrant 4, hopefully you're familiar with that. In quadrant 1, if I have an angle that's acute between 0 and 90 degrees, that all three trig ratios will be positive. All three are positive in that quadrant. In the second quadrant, so second row here, only the sine ratio was positive. In the third quadrant, that's the 200-degree angle, only the tan was positive. And in my fourth quadrant, 340 degrees, the cosine of the angle was positive. So the cast rule is a way of knowing, if I can place the quadrant where my angle lies, I'll know which trig ratios are positive and which are negative. And you might be like, well, Mrs. Logan, who really cares? And I'm like, well, it's going to come up. It's going to be important. Just you wait. All right, on to the next here. For each diagram below, I don't have my picture. Let me get that put on here. Okay, there we go. That's much better. For each diagram below, construct the right triangle by drawing a perpendicular line from P to the x-axis. So I've got a picture down here, quadrant 1. I've got my terminal arm in that first quadrant. I'm going to drop a perpendicular to the x-axis. So that's my 90-degree angle meeting that x-axis there. Determine the lengths of all three sides of the right triangle that was constructed. Include whether the length is a positive or a negative. So point P was at 3, 4. That meant we went 3 along the x, and then, let's try that again, 3 along the x, and then 4 along the y to get to that point P. All right, determine the lengths of all three sides. Now I need that third side, which is the hypotenuse. We could easily just apply our Pythagorean theorem and say c squared equals 3 squared plus 4 squared. That's going to give us 9 plus 16. Some of you might already know what that answer is going to be, because this is actually called a Pythagorean triple, or the carpenter's triangle. And I just wrote 24 and I meant to write 25. There we go. So c will be the square root of 25, which is 5. So this is our carpenter's triangle, a 3, 4, 5 triangle. We have all those lengths. Now you'll notice that they're all positive values. The hypotenuse value in my right triangle is always positive. I'm going to the right, so the x value was positive. I'm going upwards, my y value is positive. So determine the three primary trig ratios, sine, cos, and tan. And in this case, the sine of my angle theta, sine of angle theta, would equal opposite, which is 4. Notice that's the y-coordinate over the hypotenuse. That's really what we call the radius. The cosine of angle theta would be the adjacent, which is equivalent to the x-coordinate over the radius. And the tangent of theta would equal 4 over 3, which is really my y-coordinate over my x-coordinate. All right, now, in this case, in first quadrant, all three of those are positive. Now, determine your angle in degrees. All you need to do here is just solve one of those trig ratios. I'll work with sine. I'm going to do my 4 divided by 5. I get 0.8. I'm going to go second function sine on that answer, and I got my theta being about 53 degrees here, approximately to the nearest degree. All right, now it's your turn. Draw your right angle, triangle, drop that perpendicular, label your sides. So we went 3 to the left, so that makes this one -3, but then we went +4. We went 4 up. If I apply that Pythagorean theorem again, I know that this will be 5, because when I square that negative, I'll still get a +9 out of that. The radius, or the hypotenuse, will always be positive. So then when you state your trig ratios, your sine is going to be positive 4 over positive 5. Notice in the second quadrant, sine, and I forgot my theta, sine will be positive. The cosine of theta will be adjacent, negative 3 over 5. So my cosine ratio is negative in the second quadrant. And my tan ratio, tan of theta, is opposite, which is 4 over negative 3. So overall, my tan ratio is a negative. So far we've got all three were positive in this quadrant, in the first quadrant. In the second quadrant, only the sine was positive here. All right, finish that up and confirm what we have said in terms of in third quadrant, tan should be positive, and in fourth quadrant, only the cosine should be positive. Finish that up, and I'll put my solutions up. Okay, so you can confirm by our calculations here that the tan is ending up being positive in the third quadrant right here, and in the last one, the cosine ended up being positive, so in the fourth quadrant. So again, that confirms our thoughts on that cast rule, that fact that first quadrant, all three are positive, second quadrant, sine is positive, third quadrant, tan is positive, and fourth quadrant, cosine is positive. Now, similarly, if I were to solve the sine ratio on the second quadrant one, I get theta equaling 53 degrees. That gives me actually the related acute angle. My theta value would really be equal to 180 degrees. Subtract the 53 degrees. So my theta here has the related acute angle of 53 degrees, but my theta actually, the principal angle is 127 degrees. In this case, if I were to solve the positive one, the tan ratio here on the bottom, if the tan ratio, solve that, I'm going to get my theta being 53 degrees, but my theta actually will be 180 degrees plus the 53 degrees because it's in that third quadrant, and that's going to give me 133 degrees. And in the last one, because I'm dealing with the fourth quadrant, the related acute angle is 53 degrees, but my theta overall will equal 360 minus that 53 degrees. And that is going to be 107, I believe, on there. Just double checking. Yep, 307. I said 107? I don't know. 307 degrees is the correct answer there. Okay, so, and likewise, I think I goofed on this one. It should have been 233. Oy, sleep is good. There we go, 233 degrees. I just double checked to make sure I didn't make any silly mistakes there. All right, so that's our cast rule. We'll look at the next video on how we can actually apply that.